In this problem, we're looking at an apartment building. It's a 100-unit apartment building. The manager knows from experience that all units will be occupied if the rent is $900 per month. A market survey suggests that on average, one unit will become vacant for each $20 increase in rent. What rent should be charged per unit to maximize the total revenue? To sort of just touch base here and see where we are, we can look sort of at what's happening currently. Currently here, we have 100 units rented at $900 per unit. So that would be $90,000 in rent per month right now. For the rent in general, I'm going to try to maximize this rent Q. To find the rent in general, that's going to then be the number of units that are rented times the rent per unit. And the problem is I don't know what those values are. They're going to change depending how many increases I have in the rent. So we should probably count those increases. We could let X be the number of $20 increases. What am I doing? So then the number of units rented, well, it says that one unit will become vacant for each increase. So if I've got X increases, the number of units started at 100, but it's going to go down by X then. If there are 3 increases, it goes down by 3. On the other hand, the rent starts at 900, but it's going up $20 for every increase. So if there's X increases, it goes up 20 times X. And so my overall rent for the whole building that I'm trying to maximize, Q, is going to be, again, the number of units times the rent. So that's going to be 100 minus X times 900 plus 20X. I can just distribute that. I get 90,000 plus 2,000X minus 900X minus 20X squared. Or, if I clean this up a little, negative 20X squared plus 1100X plus 90,000. Okay, so now if I'm trying to maximize that, well, to maximize a quantity, I want to look for its critical numbers. So I want to look where this derivative is either equal to 0 or undefined. So if I take Q prime, that's going to be negative 40X plus 1100. And I either set that equal to 0 or make it undefined. This is a linear function. It can't be undefined. So I'm just going to get 1100 equals 40X. And so X is going to be 1100 over 40. So that would be 27.5. Now don't worry about it being a decimal. We'll see what that means here later. The idea is then, is this really a minimum or a maximum? Well, if I look at this and if I plug in Q prime of 27, that's negative 40 times 27 plus 1100, and that would be 80. That would be negative 1080 plus 1100, so that would be positive 20. so that means it's increasing there. If I plug in Q prime of 28, well, let's see, that would be negative 1120 plus 1100, so that would be negative 20, so that would be decreasing. So it was increasing at 27, it's decreasing at 28. I have my critical number at 27.5, so that is where I'm going to have a maximum. It changes from increasing to decreasing. So that is what I'm going to want here. What rent should be charged? Well, the rent then is 900 plus 20x, so that would be 900 plus 20 times 27.5, so that would be 900 plus $550, so that would be $1,450. That's the rent I should charge. Just to sort of see what's happened then, the new revenue for the whole building then, it's going to be 100. Well, this doesn't really make a whole lot of sense. In some cases, let's figure this out and then talk about it a little. 100 minus 27.5 times 900 times this 1450, and if we figure that all out, it ends up being $105,125. Of course, one thing that's a little screwy about this would say then that I've got 72.5 units rented. That obviously can't be true. So it might be that we'd want to go around here. This is just on average, and this is a prediction based on a market survey, so I'm not so sure how accurate this model would be in real life anyway. But the rent should be charged to be $1,450. In theory, that would be maximum, assuming this is correct. And that would be certainly the answer to this problem.